Good morning, everybody. Welcome to day 2 of the Update Conference. I'm hoping you're enjoying it so far. It's good to see you here. Friday morning, 9 a.m., first session. And we're going to talk about reducing third-party security risk in .NET Core applications. Long sentence, but we're going to see where we get at. So first, it's always good to introduce yourself before you start a conversation, right? So my name is Niels TANIS, and I work as a security researcher for Veracode. I got a background in .NET development. I've done it since the first bits of .NET 1.0, 1.1. And I always, my career was combined of doing application security and development. Then I moved more into the application security space, where I did consultancy and fixing security issues with our customers. And right now I'm combining all that work that I did at Veracode, where I'm focusing on our static analysis capabilities for .NET and the whole .NET ecosystem. So it means programming a lot, trying to figure out what might go wrong if people are using it, which is really fun, and it combines all my work that I've done in the past into one single thing. If you want to talk about Veracode, come see me afterwards. The problem space that we're going to cover today is the fact that if we start out developing a .NET Core application, what's the first thing that will happen once we have done .NET New in the CLI? And we say we want to have a new MVC application. It will fetch dependencies, probably from the NuGet repository, and get it in order to build your application. So technically speaking, a large portion of our app rely on dependencies that we get somewhere else. Good thing of, let's say, libraries that are open source and that are shared by everybody is that we can leverage each other's works, right? We can build on top of something that somebody else has made, and you already solved a lot of problems, so why did you need to write it yourself? So there's a lot of benefits in that, and of course that gives us productivity that allows us to write software much quicker. And trust me, I'm also a lazy developer, so you want to do least effort and get max out of it. But the thing that I have from my security perspective is okay, if you use a library, are you aware of how that project deals with security issues that are found in that library? What does the team do? Usually it's our people that do that in their spare time to give back to the community. So can you expect the same type of response as Microsoft is doing once there is a security issue being reported and they publish a new version of the, let's say, the framework itself? I believe that's, then you talk about billions of downloads that will be done at one point, right? That's completely different to an open source library that might be maintained by 5 people. So there's a bit of a skew. I think as a developer, we can be more aware of what we're using and are we using it in a way that it's intended to be used. And secondly, I think there are some good patterns that we can work on and maybe reduce the risks that we're facing with our application. So that would be the agenda that we're going to talk about. First, I want to focus on some third-party risk scenarios, because there's a variant of scenarios that are applicable to this type of risk. Then I'm going to introduce you to a really fancy MVC app, which of course is the default template, but there is some functionality inside and a component that has some issues that we're going to then try to fix by applying some isolation, so compartmentalization of the functionality, and to make sure that it will have less risk at the end. And the last bit of the presentation will be focusing on how can we, in an easy way, go over the library and skim for any issues that are, let's say, obvious, right? And that's the last part, and then it will be conclusion and Q&A at the end. So, as I already said, .NET applications, most of it will all be built on dependencies like NuGet. You might get some NPM stuff included. It's all part of your application once you build it. The other key important thing is that a developer needs to use a library as it's intended to be used, right? If you're using, let's say, some kind of a database access layer that you get from the repo, you don't want to make a mistake that you do dynamic queries and do the SQL injection, right? Which is the default security issue that everybody always talks about. You want to make sure that they make the right decisions by using the APIs properly. The projects, how do they deal with security? Another thing that's, you should be aware of it. And I think from analyzing perspective, if you look at applications, you always need to make sure that you've got the latest versions of packages. So once a security issue has been fixed, usually there's a new release, and you can get a list of, hey, these are the issues that are being fixed. Commercial tools do that. We do that at Veracode. If you use GitHub, you can get exactly the same. You can get a list of things like, hey, these are packages that are known to be vulnerable to something. Doesn't necessarily mean you have an issue, but it would be a good choice to update the package. And if you ever considered, if you have a top-level package, that there's nothing it's usually not the only thing you pull into your app, because there's a package and it usually has a tree of dependencies behind it that you will pull in as a whole graph. And that's something just you need to be aware of. And to back it up, I have some statistics. So each year we publish this report, which is called State of Software Security, in which we take our customer metrics and like see how the industry is improving or how new issues are evolving over time. We just released the 10th edition, which is like the lowest one, but in last year's edition we had a special section on third-party risk, and turned out that 86% of the .NET applications that we have seen with our service, and to put it in perspective, our service is a SaaS-based offering, so you will push your application to us, we will scan it, and it's 2,500 customers. 86% of the .NET apps we see for the first time have at least one vulnerable component, so there might be more. And to put some metrics in, Java has a bit more, like 88% almost, and C++ it's even worse. So that's by default, once we see an application first. So what happens if a component is not updated? You probably have heard of the Equifax breach. If there's any like people from the US in this room, they might have even been involved, but due to some Apache struts vulnerability that was around for, I believe, like a window of 2 months, they got hacked, and it eventually resulted in more than 140 million user records being stolen. Quite significant, and they just should have updated that single component, right? If we then move to the way that we develop right now, it always involves a supply chain. If we're doing fancy stuff, it's an Azure pipeline or GitHub Actions, it will build our app, it will make sure that we get the containers in place, it will do all the configuration. Usually that's all, like say, infrastructure as code, or the way that we deploy apps also consist of code. Keep in mind that that whole chain is something that we call a supply chain, and that can be attacked by somebody, that can be manipulated or influenced. And if somebody has bad intentions, then he might add additional functionality to that and maybe compromise your package. Keep in mind that I talked about the transitive dependencies, so the top level one and the lowest level one. If one of the lower level dependencies supply chain is breached or like is hacked, it means that your application is hacked, because that will propagate up. It's one chain. It's all belonging together, right? What could possibly go wrong then? So last year in November 2018, there was an NPM package called OpenStream, which has a 2 million weekly download count, which is significant, and that was due to the fact that this is a transitive dependency of other NPM packages, 2,000 other ones. And what happened? This is like a really, it's an amazing story. So it turned out that this package was like low level, did some work, and was stale. So there was not much active development done on this for a while. And somebody from the community got involved and said, like, hey, I want to help out. He did some patches. Then he eventually got the ability to publish packages, and he was like one of the owners. And then he decided to put in a tool that targeted a specific crypto wallet to steal the currencies. And that's what happened. And that's what happened at the end, right? So this was a person that decided to do differently. And if you see the amount that trusts on this package, and this is NPM, but trust me, other repos have the same issue. So one step back and moving back to the NuGet ecosystem, like if you're doing .NET development, we can do signed packages, right? That's maybe a solution. Phil Hack had a nice post in April this year on NuGet package signing, and it's not so trivial to do. Like code certificates are relatively expensive and hard to get. And it's not that trivial once you turn it on. Not everybody uses it, so you will have a lot of issues to deal with. If we then look at alternative ways, there is an alternative way to trust NuGet owners, saying like, hey, these are the owners that I would allow my app to use packages from. That's the alternative thing. So, but keep in mind, like signing packages, would that be a good solution? Not necessarily, because if we then look at an issue that happened in March of this year, Kaspersky Lab published something called Operation Shadowhammer. And what happened is that Asus had a laptop software that was updating their machines, and that supply chain got attacked and was hacked by somebody. And that affected 1 million computers. And the package was signed, the supply chain did all its work, there was nothing wrong with that. The only way to figure out what really happened was to look into its internals. And that's where they find out, like, hey, this is doing stuff that isn't right. This is malware that's embedded. And we should dig into it a bit more. Funny story is that they affected probably 1 million computers. They did target a small series of hardware numbers. So it was a really targeted, sophisticated attack to something. Like, we don't know for sure what it is, but you can probably like imagine like what it will be. So these are different areas of third-party risk that I'm going to touch on, like what we're going to talk about. Now let's move to the app that will be the subject of the demos that I'm doing today. And I needed to come up with a demo app, and I was like looking through it, what can I talk about? So visiting places, everybody does that. So why not do an app that administers places and the places you visited? Funny fact is that I'm not that unique in this demo because more people came up with the same idea. I thought it was good, but turned out that there's a lot more of the same demos. So let me quickly show you one thing first. So I talked about, I'm going to do a quick CLI thing, and I'm going to just want to show you a package. Let me quickly grab a terminal because this one is failing me. What's happening? Yeah. Let me increase it for you so you can see it. Dark background. Okay, cool. So if we look at this, and if we say .NET has got the ability to list packages, right? I talked about we have top-level dependencies. The demo app, I'm hoping you're able to see this, has got 3 packages, 3 top-level packages that we rely on. One is called Awesome PDF, and trust me, it isn't that awesome because I created it, but there's a dependency graph underneath that we're going to dig into, and it uses some data storage. If we now say, okay, show me what's behind it, we're going to include the transitive ones. What am I doing? Does this include transitive? You see that there are top-level packages, but if we then scroll down in that list, you will see that there's a lot more. And because we're generating PDF, this library also relies on iText 7, as you see under there. There's some crypto stuff from Bounty Castle, portable Bounty Castle. So those are all the additional bits you get for free once you start out with getting that single package in, right? And that's something you need to be aware of. So let me quickly see if I can fix this terminal thing. Yes, that's it. So let me start the app, and I'm going to show you around what the functionality is and show you some of the issues that are inside. So it's pretty straightforward. There's a list of places you can administer. So there's a name, you can type in an image, there's a piece of text. It's simple data entry, right? This is all default template work. I'm not a UI designer, you should probably have noticed. And if you press the report button, it will generate this PDF for you. It will take the image that it refers to. This is the Koppelpoort in Amersfoort, the place where I live nearby. It's a nice site. So, and it will have some text on this. Of course, there's Prague, where we're at right now. We can also generate a report. We will see the bridge. And there's one place that needs a special mention. That's the one at the bottom, which is called Middenmeer. So this is the place where I grew up, and I lived 20 years of my life. If you click on Azure and if you create an instance on West Europe, this is the data center that you end up in. It's, I think it's built a couple of years ago. They started out, it's getting bigger and bigger. But it's always funny to ride past it once I get to my parents' house, the old house, and to see that that's like one of the biggest data centers of Microsoft. So that's worth a mention. So what are the issues in this case, right? So this app generates PDFs, and the developer, myself, I've been pretty lazy. So the component itself, we will dig into the call I'm doing into the component, but turns out that the name over here is being used in order to produce a file path. And what can possibly go wrong if you do that? Of course, there's something called path reversal, right? So you're able to change the output location where the file is being written. So what I'm doing right now is I'm typing in, okay, I want to go up one level, go to the .dub root folder and save it as good morning. Let's do it like this, save. If I now generate the report, you will see it has a really funny name. If I now then go to the root of the web server, we see that the component has written a file on the top level of the web server, right? So something is happening with a dynamic path inside the component. We need to figure out if we can maybe resolve it in a way and fix that. That's problem one. The second one As you also have seen, there is an ability to load images. So if we then say, let's replace the Amersfoort image one with this URL, and this is a bigger issue I'm going to show you right now. So let's edit the image and say, like, this is a local file that resides on the server in the subfolder images. Let's save it to this URL and then press report. What the component now has done is that it has gone to the internet to grab the image, download it, and put it inside the PDF. And this problem is also known as something we call a server-side request forgery. It's a long acronym, but what it means is that the attacker has the ability to control requests that are being done on behalf of the server. So the server goes to an external resource, fetches data, and gets it back. So these are, let's say, like the two major issues we're going to focus on to see if there's an ability for us to fix the problem without changing the library and reducing the risk that we're facing with this app. So let me quickly go back to code for a bit and just show you how simple the controller is that does the reporting, because that's the bit you're going to see a bit more often. So inside this method, we have a report action that takes the awesome PDF generator, right? There is a constructor argument being passed on, which is a PDF, which supposedly looks like a folder that's been created. Then it takes the data we just selected, and then it grabs a new file result and renders that data that's being stored at that file path back to the client, right? So in basis, that's the demo, and that's the thing that we're going to work on. Let me move back to my slides and just briefly recap the demos we've seen. So the path reversal, also known as CW73, means dynamic path creation, and it gives us the ability to overwrite files or write files in locations where it's not intended to be written. There are limitations because the component itself adds the .pdf extension, but keep in mind that operating systems have got limitations of file name and paths and how long they can be. So there is options for truncation, so we might get rid of the .pdf and put something else in place. And if we then are like nifty enough to craft a path, then we can override a file in any location and then override it. And then still it will be a PDF that's written on that location, but who knows what will happen, right? It's the first step, so it has potential. The second problem, I think, is more serious, the server-side request forgery. So because the web server itself decides to download that image from the internet in order to embed it inside the PDF, allows you to also do more types of information disclosure. So if you probably can imagine, like, you can maybe access local files and get that data in, or maybe try to reach out to a local host on port 3306, which might be that there is a MySQL server running. And the last URL that you see over here is probably familiar to you. That's the metadata service within Azure. Luckily, in Azure, I think that's probably part of the trap model that they made, because by just requesting that URL inside of, let's say, a VM or something that runs inside the cloud, you cannot get that metadata by default, because there needs to be that custom header added to that request in order to work. So that's good. Other cloud vendors, in case of AWS, where Cloud One, of Capital One was being hosted on, didn't do that. And the data breach that happened in August of this year, I think it was like 100 million customers involved, was just due to this type of issue in which somebody was able to get an S3 bucket access key, and he was able to exfiltrate that data. In our case, we're dealing with something we call a blind variant. So there's no like direct relation with the data I can get back, but it's a timing window. So if I can produce an error, and if I can produce a scenario that's quicker, I have got enough information to say, like, hey, is this true or false? Is this port open or not? Or does this file exist in this folder on the system, yes or no? There are different things you can do with that. So pretty powerful. Demo set. So let's see if there's for us abilities to maybe take this functionality as is inside the application and isolate it in a way that this will be less harmful. And the thing that I would prefer to do is, like, would like to use code, and it needs to be in the same process, and I would like to use the library as is, like no changes, right? Maybe there's an ability for us to create a sandbox, or a sandbox where the PDF logic is being executed, and then we can control what's happening in there. And you would think, like, okay, within a .NET framework, we probably have components that do that, and yes, we have, right? So in the past, system.app domain was supposed to be an isolation boundary for security, reliability, versioning, and unloading of assemblies. And the people who have worked with the first bits of .NET probably know a concept called code access security and the trust levels we had in ASP.NET that allow you to, let's say, in a shared hosting environment, limit the .NET API calls that somebody could do. So if there was an IIS server that ran all the customer sites, then if somebody did request the temp files in the .NET context, you weren't allowed to do that in medium trust because that will also grab the temp files from the other people, right? As from 2017, it's not supposed to be security bound anymore because it's like easily broken. There's a mutex in memory that you can manipulate and turn it off. I've got some code if you're interested in how it works. And also, app domains in general is like not supported within .NET Core. We have a single one once a process starts, and that's it. And the whole trick we want to do with app domains is like you want to have like a single one that creates a second one internally, and that will have the limited rights. That's how it was working in those days. Luckily, there is a replacement in the framework itself, and that's called assembly load context. And that has similar capabilities. It can do mostly loading, resolving, and unloading of assemblies. The demos you see from inside the GitHub repo mostly focuses on multiple versions of the same type of DLL that runs. So there are examples on when Newtonsoft.json has different versions and it will be executed by the app, and one uses the first one and the second one. The thing that we're also going to use in this demo is self-contained deployment, and I just want to briefly touch it. So that means that the application itself will be deployed as is. There's no relation to a shared folder where the .NET, let's say, shared libraries are, right? There's a fallback folder in your system. I just want to have a folder, have full control of what's inside, because that's the whole thing I'm going to use for isolation, because if we then have the PDF functionality isolated, maybe we can pick out stuff and say like, hey, you're not allowed to do this, and that's the end goal. So the work that I've done for this, I've presented earlier this year, but it was inspired by a plugins library that was created by Nate McMaster, who used to work on the ASP.NET team. And he has a similar pattern, and with .NET Core 3.0 assembly load context, the scope was changed, or it was not abstract anymore, and more internals were exposed to the outside. So it was easy for me to also create a basic implementation. So that's exactly the thing I'm going to show you. And we're going to dig into how we can isolate these things. So let me open up the second demo. So first thing, so we're going to use the concept, we have, every app has its own assembly load context that will be the default. That's the default, and we're going to create a second one underneath that will be responsible for loading the PDF library and taking care of all of that. We need to have a shared contract, so we want to be able to instantiate it in the first assembly load context, and it needs to be matching type. So first I need to define an interface that we're going to use, and the naming is not as good as it's supposed to be, but it fits the needs. So IPDF service, you see over here, if you can recall oh, thanks. I should stop the presentation, hold on. You will think like, hey, what is he talking about? So there's the interface. It's up, yes. Signature matches the thing that we've seen before, right? The library and how it's invoked. That was like the main goal. Then there is the library itself. This is a class library, and as you see, the only thing that it, in this case, references, it takes a package reference to the awesome PDF component, right? That's the change, and it has a project reference to the interface, and that's the thing that we're using. And if we then look into the implementation, it's pretty straightforward. There are two lines which I will cover later, once we are doing a debug demo, because it's important to look at some of the code base locations. And then we do exactly the same. We just take the generator, instantiate it, and take the same arguments and pass it on. So for favorite places, the host app where we want to use this, this functionality, we of course have removed any reference to awesome PDF. That's the thing that we want. And the only thing that we added was, again, the interface library in order to have access to it. My apologies. And then the magic happens inside of our custom load context. Don't try to understand fully what's in. All the code that I'm showing right now is all on GitHub. I've published the repo yesterday, so it should be available. I'm just going to briefly touch some of the things that are important for the decision making and how it loads the assemblies itself. One thing we need to keep in mind, because there is a default assembly load context and there is the interface that we want to share across, the type needs to be exactly the same. If I would have just instantiated the same interface inside a second assembly load context, the types won't match. Although it's exactly the same, it will clash and it will throw an exception once you try to execute it. So I need to keep track of some of the shared types I want to have between the isolated context and the main one. And from that, I will store the assembly where those types belong to. That's the important thing. The other thing that's part of the .NET framework itself, it's the assembly dependency resolver. And that's the component that the framework itself also uses once it starts resolving and loading assemblies inside a folder. And we're just going to rely on that. And the decision making is being done in the way that we load our managed libraries. And that's the assembly load function you see over here. So once an assembly name will be passed on, will be loaded, first going to check if it matches one of the shared types. If not, or if that's true, I'm going to say to the default context, please load that type because you need to use that type in order to instantiate. Then we're going to say, resolve it based on the default framework logic. And if we're then unable to find it, what you usually see is that this context will propagate back to the default one and ask that to deliver the assembly. But that's exactly what we don't want. We just want to have a hard stop. Like if I'm unable to find the managed assembly in this isolated piece, then stop the execution. And that's exactly what I'm just saying here. We need to do similar things for unmanaged code, although this is a bit of a half implementation because I'm still relying on the fact that the default assembly context will provide me if I'm unable to find. The APIs that we're isolating here are fully managed code. Underneath there might be unmanaged libraries, but let's just ignore the fact. That's probably going to be the next version of this implementation that I'm going to focus on. First thing, managed code will be isolated. So that's exactly what we're doing. And then, of course, we need to have the ability for the MVC app to use this interface and to get an instance from this isolation context. And within our configure services, once again, not the most cleanest implementation, but it works, we see that I'm instantiating the isolated load context. I'm defining, so the PDF library you saw earlier is being published as a self-contained app in a subfolder, and it's part of the app. I'm going to run a couple of build scripts, shell scripts, to put everything into place, so it will be in that folder. Then we're going to say instantiate the context, create a load from assembly name, and then iterate over all the types. Once you have found something that matches the IPDF service, that's the thing that we're interested in, we're going to just say quick and dirty, create an instance, add it to our services container so it will be available for our DI to use, and we're going to break out. And if we then look into the places controller itself, we will see if we go up into the constructor, there's that IPDF service. This is the only thing it knows, right? The interface. And if we then go to the report, we see that we've replaced it with similar calls, only it's on the interface and not directly on the component anymore. So as I said, I'm relying on self-contained deployments. So I'm going to do a build script that does exactly the same. It will do a publish, it will put it in a folder, which is one level up. And I'm going to do the same for the PDF library. If you want to see what's inside, as I said, it's all in the repo, which will be in my last slide. If we then, let me maximize this one for a bit that you can see it. So if you then go up, there's a lot of files, but there's one folder called my PDF library, and that contains all the things that happen, like all the things that the PDF library uses, and we'll level up, we have the app, right? So that's it. Let's start the app. I'm going to do an attach from VS Code. Let me see if I got the right breakpoints in place. This is the one, yes. So let's go back. Supposedly this is working, right? This is the same app, only we have replaced it. If we now generate a report, let's take Amsterdam for example. We see that we end up in this controller method, and this is of course where the interface gets called. If we then trace into, we end up in the separate library. And funny fact, like we step over these two calls because I want to show you. So in this case, the myPDF library belongs to that published folder and then the subfolder, right? The HTTP client it uses is also system.net.http belonging to that subfolder. So internally, we're going to review the bits of the library later on, but it uses HTTP client and it does a getStream async call in order to get that image internally. So I'm interested in grabbing that one and maybe take it out or do something else with it. So if I'm now just continuing, we will get the report. We can do the same. Can we still do the same with this? So if we say edit, save it, report, continue, continue. We still can do the same. This is the external image again. So let's just be rude and let's just delete system.net.http and see if we can maybe take out the HTTP client and then only focus on the fact that we want the library only to load local images in the file system, right? That's the way to reduce the risk. Still, there might be some issues with server-side request forgery, but it's more controllable. So let me quickly stop debugging, go back to the terminal. Control C. Continue on shutting down. Okay, cool. So maximize. So if we then move into the folder, and as I said, let's just say, let's just remove the DLL and see what happens. There's no need for us to attach the debugger right now. This should be fine. So what if I now press the report button? What's happening? I'm hoping you're able to read this. So it says, hey, file cannot be loaded because we're missing this type. And to show you that I'm not tricking, this is the assembly load context. And is there still the ability for us to load a file? Yes, because this is the main assembly load context, and the call inside the controller will do exactly the same as the component is doing. It will fetch that file based on the given URL. So this is the HTTP client in our main process. So we've taken it out of the thing that belongs to the subfolder, and we can still use it in the main app. So partly we've achieved at least having control of that instance. But what if, hold on, I want to create a report based on an image? It still causes the same problem. So there is some loading of assemblies or some code path that will be executing that will still have the need for system.http client to be there. So why not replace it with a stub and show like, hey, you're not allowed to use this. And that's exactly what we're going to do. I want to have this one, Control R, escape, come on. Do it like this. Let's go to this one. Just a default implementation, matches the namespace, same class, method. So this folder also has a build deploy script for my convenience, because I'm not going to type in it again. But what it will do, it will take this system.net DLL and it will replace it with the one we have seen, we have removed before. So if I now go back to published, and if we start favorite places, and if we say, okay, go back to places first, if we now generate the one with an image, it's completely fine. And if we now take the one that has the URL, then we get the exception that we have just introduced. So what I'm doing here is just replacing the implementation with something that I don't want to use. And this is a concept thing. I would not suggest you to do this in production, but I think it has potential in creating a tools around. And just to briefly recap what we have done, we've replaced the functionality with that interface implementation inside that library, and then we added it to the DI so it's available. And we replaced the system.net.http client with our own implementation, and still allowing the main process to use it, or like the main assembly load context, but our own not. With .NET Core 3.0, there was an introduction of the IL linker that was used to reduce the size of the .NET framework. If you're doing, let's say, WinForms apps, then it would be nice that the executable is as small as possible. And that will always be a self-contained thing, right? It will have all files you need inside the folder. So what they did is like they did some, I believe it's called tree shaking. They will look for all the types that it uses and strip out the types that you don't use. I think we can maybe do maybe a bit more aggressive and even strip out types that we don't want the library to use. You still have the risk of applications not working as you have seen before, but it's a sort of micro patching. And if you really want to fix this problem, I think that's an area where we can improve. There's also something called Harmony, which is a transpiler that will do at runtime replacement of IL. I will be more in favor just to rip it out of the DLL itself and have it not available, because that's of course better. Keep in mind, once again, like this is solely focusing on the problem, the security problem inside the library. If we would have done input validation, then of course the risk would have been less, because you cannot reach that path if there's like a constraint on only a name is allowed to be used in file names, and for example. But still the library internally has that problem, and I think you want to fix it. So this is the problem that related to server-side request forgery, and how can we fix the path problem? And that's a more difficult one. The only way we can solve this is to do something with a separate process. So if you would have liked to have more control over where a file gets written, then we should maybe have some RPC style of thing in order to do that same PDF generation. So in my demos, you will find a named pipe solution that will do the same, that will have a separate process for the PDF generation. And if you then have a limited user account that only can write files to location X, then you have also like mitigated the problem. The other problem I would solve is not return a file path, but return the byte stream of a span of bytes for the output PDF to get random back, right? Not rely on the fact that there's a shared path, because that's the basis also of the path reversal issue. This is inside the demo project, and unfortunately I did not have enough time to do a GPRC demo, which was like, of course, with .NET Core 3.0 released, but it will do exactly the same. If we then take one step back, like what's the thing that we need to do from software development? If you would do this type of PDF generation in an enterprise context, would make sense to maybe have a dedicated microservice that does this, or a container that does the PDF generation for you. And of course you will always have, let's say, least privileges. You will lock down the container. It's not supposed to go to the internet on its own, like it won't like grab resources. You lock it down. If we can also then patch our software, then we have layers of defense. And I think from security perspective, that's always what you want. You don't want to rely on a single spot. No, you want to have multiple layers. And if one fails, then the other one is still in place, and it will be still a small thing. Keep in mind that Capital One thing, I think they even locked down traffic. There was a web application firewall in place, but they could not, its functionality of the app, they could not like block that request on getting that metadata information that will eventually got all the breach data out. So I think with the like the demo I've shown is mostly a monolith application, because everything was inside that single process, right, inside that MVC app. But with microservices and with serverless, we're like more in control, and we can do smaller things, smaller responsibilities, and lock those things down. And still, there's always a need to fix bugs and to fix vulnerabilities and security issues. So we focused on a practical approach on fixing this, and now let's move to a way of how we can review libraries and to figure out if there's something inside that we should worry about. Keep in mind that there's a difference between components and frameworks, or at least I want to just like explain it a bit, because the PDF thing you've seen is a component, it's on its own, and MVC itself is a framework you build on top of, right? It will be much harder to isolate stuff in that because you rely on that, it's the whole stack. And if you have a separate thing, then of course that already screams for having a separation inside of another, maybe service, microservice, or container or something else. We're gonna do some reversing, and I'm gonna do some reversing on my own component and on some others. Keep in mind that you always need to comply on the license model that's being met by the component. It's not always allowed to do a decompilation of DLLs. That's just like my disclaimer. And if you want to do it, and if you need to do it within your organization, talk to your legal department. Talking about intention, this is always a question I ask. I've included this in all my presentations. And the question for you is like, what's this? Looks like a controller, right? Because it's a data controller, and it has a function that gets file data, it has an input string, and it will then open up all text of the file and return it back. But are you sure this is a controller? It solely depends on the context where it's being executed, right? If this is part of a project that references MVC, then this will be a controller, because that's the way how the convention-based resolving works. If this is inside of a third-party library that also references the MPC framework, this will be resolved at runtime. So always keep an eye out for controllers inside of your third-party libraries, because they will be exposed by default. And convention exposing is nice, but this is one of the downsides of it. But be aware, it's all about context, and differences is that this will be resolved because of the naming, and once the reference is in place, then that will happen. So let's move to review, which is the last demo that I'm going to show you, and I'm going to show you some code. So I've written a really easy tool that uses mono-CSIL, which is a library that allows you to open up IL and look inside. Let me quickly switch the slides off, because I'm making the same mistake again. Where is it? There is it. And show. Okay, cool. Now everybody is able to see my screen. So we're going to focus on this. This is a tool called Fennec. You will find the resources later on. But what it does, it uses mono-CSIL, and I'm just going to walk you through. Like, there's no need to fully understand what's happening, but I'm going to load an assembly. I'm going to look every module that's inside, which is this call, like multiple modules. Then for each class type, I'm going to iterate over all the methods that are there. And if the method has an implementation as a body, I'm going to spit out all the instructions inside that method body. And I'm going to write it to a file. And that's what I'm doing. So it's pretty straightforward. And it will create a single line of a call that's been done. So each API call, so file.open, will have a single line inside this file. So what we can then do, and it's on NuGet. It's the first version. It's also it works. I need to work on making it, let's say, more verbose and allowing it to give more feedback. But you can install it throughout the global tools from .NET. Let's move back to the published one we had before. The published folder. And then we go into the myPDF folder, because that's the one that we're interested in doing. If I now say Fennec Net Core, and I'm going to define an output folder that's just for my own convenience, I'm going to say I would like to see the contents of awesome.pdf. And I would like to have all iText DLLs, because that's the one that's using. It will run. As I said, it needs to be more verbose, but trust me, it's doing something in the back. It has produced files, plain text files, like pretty large in size. And let's just open up this folder with VS Code and let's see what's inside. And I'm seeing that I'm missing out one more. Hold on. Is this the one? It looks like it's not containing. It does. It's there. So Fennec netcore awesome.pdf.dll. And then move that awesome to that same folder, because that allows me to use it inside of Visual Studio. There it is. That's the one I was looking for. I have no clue why it didn't show up at first. So, as I said, once again, there's a lot of information, but you will see that this is just the method signature, which will all match, right? This is a one single block thing. And if we then look inside, we will see like this is the whole method body, and it doesn't have all the conditionals that it does at runtime. Let's say like if this is true, then it solely is API calls. And what we see over here, like we have some sense of what's happening. It will create a PDF document, and then at some point it will do the image data factory, and that's the thing I'm interested in seeing. So because I also dumped the same type of structures of the iText ones, I can search for it. And if we then look into that, we will see there's a lot more happening. It will create an image, there's some conditional stuff, and so on. let me quickly just search for the use of HTTP client, because I'm not going to bother you with all of it. So at some point in that code base, the awesome PDF uses the PDF document, uses itext sharp, and then it will use the URL util OpenStream method. And this is exactly the code path we have just manipulated. So if we, let me highlight the function. You can see this is the block. What it does, it says, hey, is it a file, is it a local path? If it's a local file, I will open up the stream, return it back. Otherwise, I will take the HTTP client and grab the stream. And this is exactly the point where we patched that request, server-side request forgery issue that we saw earlier by replacing the getStream async method over here. So this tool is pretty verbose. There's a lot of information being displayed. Let me quickly go back to the slides. So as I said, this is exactly what we want. We've replaced the HTTP client, so we have taken care of at least not allowing at runtime to download files, which takes care of the server-side request forgery issue. And unfortunately, the path thing can only be fixed by doing the second process and isolate it. So the tool, it's starting out. It even has a nice logo. If you want stickers, I've got stickers with me, but you can find it, and it will just do a dump. And the next thing I was planning on doing is, it would be nice if you can do it inside of a build step, maybe produce those files on libraries and then do a diff. And it's not the same as doing a full review of a library, but it will give you some sense hey, if somewhere else the word of binary formatter shows up, then you should start to get itchy, because that's one that causes a lot of problems in .NET nowadays, right? But it's a simple tool. It can just produce quick files. The other one I'm planning on doing is doing a JSON structure of that method, push it inside of, let's say, Cosmos DB, then use Gremlin APIs to do some recursive things. You probably already think what I'm heading, because then you can do some data path things, and you can define even locations where you need to look for. Then we're almost writing our own static analysis. That's cool stuff. So I'm gonna wrap up. I think in general, the takeaway, I think it's important for developers to be aware of when you're using libraries, what's happening internally. Make sure you review components for things that you do not intend, you do not expect it to be inside. As I said, why does component X need to have this API call? Doesn't make sense to me. Then you should be worried, right? Think about that ACES scenario. It's always good to make sure that you isolate logic. And by code, we can maybe work on a concept that I showed earlier with the assembly load context, or you should make sure that you have an architecture that fits the needs, with the microservices and locked down properly. And still, I would think it's a good idea to also rip out APIs that you're not using. And of course, development lifecycle and security, it's important. As I said, developers need to make sure that they fix the bugs. You don't want to have missing input validation, as my demo had, right? Because that would have taken care of a lot of the issues already. So it's the whole story, and we need to, of course, do good in all of it, and this is just a small bit of it. So this is it. Thank you for your time, and I think we've got 1 minute and 45 seconds left for questions, and I believe there's a microphone if somebody wants to ask a question, or otherwise I will just repeat it if I'm able to hear it. And if not, I'm going to say thank you. I will be around the whole day. I'm going to be here for a while, so thanks for your time. Enjoy the conference.